Hello everyone, I'm Jackie Ritchie and today I'm going to be presenting along with my co-authors Giselle and Jessica, the COMFlex designer, an adaptive haptic interface with shape changing and weight shifting mechanism for immersive virtual reality.
The process of designing products has been improved immensely over the years through the implementation of various technologies. Physical products are now often designed virtually before moving through the series of physical prototyping steps in order to achieve a successful end result. Using CAD to model designs enables the designers to visualize their design in 3D. These virtual designs are invaluable, but the designers still lack the physical feedback. So, a physical prototype is required to provide tangibility to the design. Validating the design is an iterative process, as the physical model would have to be updated with each subsequent change in the design, resulting in this being a very time and resource consumptuous process. This is the motivation for the COMFlex Designer, which is a device intended to be used by product designers in VR. The COMFlex is a device that is intended to represent the virtual object and respond to changes in the virtual object. So the changes in the product will be made in the VR environment, but will be reflected by the device, which would be perceived by the user or wearer as tactile feedback. This enables the designer to physically interact with their model in VR. The system consists of two devices, the COM and the Flex. The COM reacts to changes in the center of mass of the virtual object, while the Flex reacts to changes in the shape of the virtual object. The COM and the Flex are controlled by an Arduino embedded system. The Arduino communicates via Bluetooth with the PC, which is simulating the virtual environment in the Unity game engine with the Steam VR plugin. The COM and Flex make up the COMFlex, and together they dynamically respond to the changes in the shape and center of mass of the virtual object. So as an example, in the VR environment, if you picked up a hammer, your hand will not only feel the shape of the handle, but the weight of the hammerhead. This will occur as when you pick up the virtual hammer, the servo motors on the Flex will work to rotate the plates to reflect the shape of the hammer handle, while simultaneously the stepper motors attached to the COM will work to shift the masses to reflect the center of mass of the virtual object. This feedback prior to physical prototyping will not only enable designers to make better designs, but also reduce costs through requiring less prototypes.
Most of the testing were done internally, with students and researchers involved in the project. Different VR scenarios were created to assess the accuracy of the perceived shape and weight. Other factors such as intuitiveness, usefulness, and comfort were also rated by the users. This is one of the test scenarios. Different objects with cylindrical handles of varying diameters were shown in a VR scene. The aim of this scenario was to assess the accuracy of the device's shape-changing feature. Another scenario aimed to simulate the movement of liquid inside a bottle. This aimed to test the real-time accuracy and performance of the device. And lastly, the plane scenario aimed to evaluate the accuracy of the COM's center of mass adjustments. The orange dot in the photo shows the tracker on the back of the user's hand. In VR, the users can see plates with indicators which they can use to map the perceived center of mass.
We also implemented an exploratory immersive gaming scenario in the form of a fishing game, where we gave haptic feedback in the form of nibbles using the COM device. Based on these scenarios, we came up with a number of findings. For the tool design scenario, we found that the shape of the object was slightly accurate, the scene was intuitive to navigate, and that this device would be useful for designing tools. With the water bottle manipulation scenario, we found that the weight in the user's hand represented the weight of the water bottle, but the movement of the weight was not fast enough to keep up with some of the user's quicker motions, which meant that we thought we could fix that with a more viscous liquid or faster motors. The COM device was accurately estimated by the users for the two plates that were divided in half, but when we partitioned it more, they became less accurate. However, the wrong guesses were consistent, so we thought that by moving the plate projected in the back of the user's hand to a different position, that might fix those discrepancies. The immersive fishing game was really well received. The weight feedback matched the weight felt in the user's hand, the enjoyability of the game was enhanced by the device, and the game was very intuitive to play, which is encouraging for different applications of the device. Some ideas for future work would be some minor adjustments to the system in order to improve usability and robustness during testing. We'd like to do a formal user study with more participants, and we could also program the Flex for different shapes, as currently it only does round shapes, and we'd like to look at more scenarios with a variety of applications, possibly leaning into simulation and gaming applications. Thank you very much for listening to our talk today. Thank you to Agent Kai for allowing us to present, and please ask any questions that you have afterwards.